What we then want to know, of course, is how large are they for the current example, and how could we calculate them? Well, the regression line has been drawn in a particular way, of course. As we said, we draw a line of best fit in the sense that it should follow the points as closely as possible. And from that criterion, you could say, a few simple formulas have arisen. There are actually multiple ways in which you could calculate B and A, but I feel that the following formulas are a relatively accessible method. This is how you could calculate B. You would take the correlation coefficient. So this is then assuming that you already have the correlation coefficient. And you would multiply it by the standard deviation of y divided by the standard deviation of x. There is a reason behind this, of course. I like explaining the ideas behind formulas, although this one is a tad complicated. So what I decided to do is I decided to leave it for a bonus section in my book. So that's often a thing, if you're like, I want the nitty gritty. Check out the bonus section, in this case in chapter 3 of your English PPP book, if your life wouldn't be complete without knowing why this formula is the way it is. But right now, let us suffice by filling it in. So then you take the correlation that we had earlier, 0.606, and you also put in the standard deviations. Actually, if you don't round any numbers in the entire process, right, because the correlation as well as the standard deviations that we have here are somewhat rounded, and in this case we get 1. Perfect slope of 1, unrounded number. So how would you interpret this then? How would you say the 1 means what exactly? In a nice sentence that fits with the example. 1 what exactly?
Yeah, for every additional appetizers, there's 1 additional drink ordered.
Yeah, right. We expect customers to get for every additional appetizer that we serve to a customer, we expect them to order 1 additional drink. So that's actually a very straightforward relationship there. The slope can also be something else than 1, of course. Could also be 2. It could be 10 if the cook uses a lot of salt. It could also be around a decimal place, number with decimal places, 0.267. All of that is possible. But here it is simply 1. 1 additional appetizer, then we expect 1 additional drink. Well, okay. Next, there is the intercept. And this is then one straightforward method to calculate the intercept, to take the mean of the dependent variable, the mean of drinks, and then to subtract b times the mean of x. The logic behind this formula is even simpler, but because I've already left the first one in the bonus section, we're going to leave this one in the bonus section as well. If you just want to look at this one, that is, poop simple, as we would say in Dutch. So be sure to give it a try. And then we just fill it out. 5 minus 1 times 3, and that gives us 2, an intercept of 2. How would you put that in a sentence then? An intercept of 2. What does that mean for this in this particular context?
I don't remember the name of the variables, but when there are 0 of the independent variable, which was what?
Appetizers?
Appetizers, there will be 2
Drinks.
Okay.
Yes. So we expect customers that are not given any appetizers to still order 2 drinks, which is reasonable, I feel, if you're there for dinner. No appetizers, then we still expect 2 drinks ordered. That is what you might call the baseline behavior of our participants. Okay. And then that leads us to then the specific concrete regression equation for this example, you could say in this case, what we have is y hat is 2 plus 1x. You should leave the x and the y in there, because they are still our variables. These can differ depending on the person. But the 2 and 1 are fixed, as you might say, as they describe the overall trend in the graph.